Oh, hi, I didn't see you there. My name is Javon Jenkins, and today we're going to do a refraction and reflection lab. And in this lab, we'll be trying to find the index of refraction due to a prism. Now, we're going to be using Snell's law in this lab, and Snell's law is n alpha times sine alpha, which equals n beta times sine beta. Now, doing your basic algebra, we find that n beta equals sine alpha over sine beta. And later on, after getting our measurements and our data, we will use this equation to find the index of refraction due to a prism. Now, in all experiments, we have what you would call percentage errors or uncertainties. And in this case, we'll be using this equation, which is delta n equals n times cotangent beta times delta beta plus cotangent alpha times delta alpha. Now, moving on, alright, now, in this lab we have a laser, a jack, a clipboard, a piece of paper, and a prism. Now, what you're going to start off with is this prism parallel with the laser. Now what we want is for the prism to turn a little bit to the side, enough to where in our measurements we get over 45 degrees. Now that you have your prism set, you're going to find the beam of the laser and make a small mark and another one further down. And then you're going to come where the beam enters the prism and follow it towards the laser and make another incision or mark. Alright, and now once you have that, you can now just trace the prism. And now you can remove the prism. Now you take your protractor, and what you're going to do is you're going to connect the marks to the prism. And then you're going to go to the other side. We can now turn the laser off. Now, you're going to go back to one of your points and make a tangent line, which is perpendicular, by the way. You're going to make a mark, and you're going to connect that line. You're going to connect that line all the way through the prism. And then you're going to come back onto the other side and make another tangent line, which again is 90 degrees. And now, you can now connect your 2 points. And now you're going to find the angle here, 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 and here. And these angles are gonna stand for your alpha and your beta. Now, we find that this angle is 59 degrees. And if you did this correctly, the other side should be 59 degrees as well. If not, again, it will be calculated in your uncertainty equation. We find that this one is 61 degrees. So we see that there's a difference of 2 degrees, and now we're moving on to the middle. And we find that this one is 36 degrees. And moving on to the next angle. Again, they should both be the same. But in this case, they're not. We find that this one is 38 degrees. Now, we know that there is a 2 degree difference, so we are just going to say that both of these are 37, and both of these are going to be 60. And now that you have all your data, we can now move on to our equation.
Everyone, my name is Tunde Salawu. I'm going to be showing the calculations for the uncertainty of the experiment that we did. From the experiment, we realized that alpha is 60 and beta is 37 degrees. And once again, we use this, it says that alpha is equal to beta is equal to 1. And the sign of 1 is equal to 0.017. And based on the Snell's law, we have alpha is equal to sine alpha over sine beta, which gives me sine of 60 over sine of 37. And from that, I get I get 1.43. Now we're going to use the n number to find the uncertainty. And then we have 1.43 cotangent of alpha. Alpha, we know alpha is 60 plus cotangent of 37 times alpha, which we said that is 0.017. Cotangent of 60 So based on the answer that we got, this answer is just showing the uncertainty of the experiment that we just did. So from solving this, the calculations, we found out that n is equal to 0.046. The equation, I changed this from alpha to beta. After solving, we figured out that delta n is equal to 0.046.
And in conclusion, now that we have both in beta, which is 1.43, and our uncertainty, we now find that the index of refraction due to the prism is now 1.43 plus or minus 0.046. And that